Live now. Hello, hello. Yes. Hello, this is Irene here with SaugaTalks and Brian Thomas from Coruzant Technologies. Hello, Brian. Follow us. I forget to ask our audience, okay? Follow us, Coruzant Technologies, LinkedIn, SaugaTalks, LinkedIn, YouTube, Twitter. You can find us everywhere because we talk to amazing people every week here, live. And audience, if you're tuning in, you have an amazing opportunity to comment live, to get the answers live. That's what this is all about. And today, we're so extremely privileged to have Tomas Svoboda back to our show today. Tomas,
Oh,
welcome back.
Welcome.
hello, Iran. Hello, Brian. Nice to be back and talk with you again.
Lovely, lovely. So let's start with Brian first, because Brian and I collaborate in the best way possible. We're bringing live guests and live topics every week. Brian, how you feeling ahead of this? What is it? Facing the longer weekend in the
Yeah,
US?
longer weekend for those that are, outside the United States. We celebrate July 4th or Independence Day from about 240 some years ago from Great Britain. So it's our independence we celebrate, and we wish everybody a safe weekend and continue a beautiful, independent, free enterprise government. So there can be more love in the world. Anyway, enough of that. I'm excited today, not because necessarily the long weekend. I do like that, but we got a guest again that has come back to us because of some stuff that he was not able to share last time, and we've got just a huge. I personally got a response from a bunch of people that want Tomas back on the show. So I am so excited and privileged to welcome him back again. So Irene, thank you.
Yes, absolutely. That's what we're here for, because Tomas, we saw comments, we saw incredible feedback following our first session. So we're going to link our part 1 in this video for sure, so people can enjoy today's talk as well as previous talk. So Tomas, we want to talk about today, not about NFTs in particular. It's the hottest topic out there, and I know you do a lot in that area. Let's kind of bringing up a notch in a way that in practical ways, right? When companies, manufacturers, enterprises still struggling to implement the latest innovations available, okay? I see huge gap between what's possible and what's actually companies, feeling safe to try and feeling safe to experiment with in terms of technologies and all new methodologies, okay? So we declare this topic as Industry 4.0 focused. Okay, let me bring the broad overview. Where do you see Industry 4.0 is now and where we're heading?
Okay, so thank you for this introduction. And I will maybe start why I can talk about the Industry 4.0, because I had to meet it personally during my business way and my development way. And I spent a lot of time in automotive or automotive-related companies. My first startup was focused to inspection in the production, especially the X-ray inspection, and that was what brings me or bring me to the field of Industry 4.0 and discovering what does it mean. Because for most of the people, Industry 4.0 is some kind of buzzword. Yeah, they doesn't understand what is it, and some simple explanation is that Industry 4.0 is a set of some visions and some ideas and tools and their possible implementations, how to move today's industry to the next level. Because over the time, there are lots of new technologies, but in industry field, you cannot implement every new technology every year. Yeah, because you have to keep your business running and you have to produce every day the lots of pieces. So it's very hard to implement any new technologies in it. And after some time, after 10 years, 20 years, this cycle's going and it will continue in the future. So we will have Industry 5.0, 6.0 in future. But now there is prepared some complex logic system of the tools and ideas, which factories can implement together to totally reshape their organization and skip to new kind of the production. Yeah, I prepared some small image, and I hope the people will see it. This is how the information systems and the data and systems in the factory was connected in the past days. Yeah,
it's hard to see, Tomas. Can you talk us through? Yeah.
It was automation pyramid. Yeah, most of the factories which implement lots of ideas from Industry 3.0, like automation, advanced robotics, and whole automation of assembling the products. They bring lots of technologies to their production field, which must communicate together. Yeah, in the past days, it was covered with some PLC, some programmable logic controller, and over this PLCs, which can control the whole production lines, but on production field you have, for example, the 20 of these production lines, and on each production lines you have lots of stations, lots of robots, lots of pneumatic cylinders and whatever, and you have to collect the data from it. And in past days it went to some SCADA system which controls these technologies from the field of the process. Then, if you was lucky, the company owns some MES system, which can create some middle layer to control these the production field, and connect it to some ERP system which plans the resources across the whole factories, and connect this layer again upper to some financial controlling of the production, and then it went to data storage. But when you want some information from the production field, for example from the robot, you had to go through all of these layers. Yeah, that's why it's stacked as the pyramid or some onion. But when you have too many of these technologies, and after past 10 years, each company invested huge money into new technologies, and they have now lots of them. It's very hard to keep all of these connections updated, and it creates the much more connections between the systems than it should be needed. Yeah, and that's why the Industry 4.0 brings the new system of architectures, how to connect these systems to get this information with as many low connections as possible. Yeah, so you are trying to minimize the connections, but it needs the total reshape of whole information systems in the factory, and it's for most of the factories it's almost impossible. Yeah, because you cannot turn your factory for a month, reshape everything, and then restart it. Yeah, you have to do it during the production. So I'm glad that big companies or bigger companies, especially in automotive, have multiple factories, because they can do it in, for example, one factory, and then they can copy this system, and some smaller factories, which is, for example, tier 2 suppliers in the automotive chain, they can re-implement these ideas too. Yeah, but it will take a long time. So, for example, if someone talk now about Industry 5.0, it's impossible to implement it because the factories are not ready, and they don't have ready infrastructure for handling all of these data.
Tomas, what about digital twin technology in manufacturing? I hear a lot. I had speakers talking about it here. So digital twins in manufacturing, yeah. Mm-hmm.
So the digital twins, it's a part of the ideas of Industry 4.0, and it doesn't mean some 3D model, because most of the people just imagine that you have a robot and its digital twin is some 3D model. It's not. It's a data model, because Industry 4.0 is mainly about the data. Yeah, the automation and some virtual reality and these fancy stuffs, It's just some small nodes in the whole industry 4.0. Without the data connection, you cannot do any of it. So the digital twin, in the real meaning in Industry 4.0, is some abstract implementation of some real asset and describing its properties and its functions. Yeah, because if you imagine that you have some time which flows in the production, you create some, for example, steps each 1 minute, 1 hour, whatever, and in this moment you will record the existence of this entity, for example, the positions of robot, motor hours, if it's running or if it's stopped, and you will save this representation of digital twin into some unified namespace, yeah, which connects and allow the sourcing of this data to any system in your factory. Yeah. So the digital twin you can do for anything. If you have at home the television, you can describe the digital twin, for example, on paper, and to create a digital twin of your television, because you can check if it's running or not, what program is running inside, how big is it, how old is it, yeah, and all of these parameters you can describe to this digital twin. So if you want to explore the real meaning of the digital twin, just go around your house and try to or select 10 items and describe their digital twin, and you will understand how many parameters you can get for each thing what is around us. Yeah, just the simple pneumatic cylinder. If you have some cylinder like this, the very classic some cylinder which you can open and close, it has about as minimum 10 parameters which you can describe and check in the factory, and most of them can bring you amazing savings in your whole process. And that's what Industry 4.0 is. The exploring these parameters captured to these digital twins, analyze them, and then feedback this data into the production to make your process better. For example, this cylinder, you can measure how fast it takes to open it and close it. And over the time, it will get stuck. Yeah, for example, in 3 years, this cylinder will die and it will stuck during your whole production. It can stop you whole production line. And if you produce in automotive 1 part each 15 seconds, it's a lot of loss what it can cause. But you can predict where it will stuck, because you can measure this opening and closing time, and after time you will see that it's slowing down. Yeah, so you will, for example, create some first threshold which will tell you, okay, this cylinder is slowing about 20%. It's little risky. Let's plan there some maintenance. Yeah, some preventive maintenance during the weekend when the production is stopped. So you can check everything if it's really slow, because you can measure it with some tools and compare it with this long-term data. You will decide to replace it, because it will cost you maybe $100 and it's worth it, because if it will stop your production line even for half of an hour, it can cost you the thousands of the dollars.
Yeah, being a bottleneck, right? Bottleneck in your process, right? So, Brian, you have, yeah.
And this is some kind of maybe better case, because if this valve or cylinder will start, you will see it almost immediately, because it will affect the production and nothing can be produced on the station. But when, and Iran, thank you for this word bottleneck. If you have it in some critical part of process where it can cause the bottleneck, even slowing down for 500 milliseconds can decrease the OEE, some overall efficiency of the whole production line, about, for example, 1%, 2%. Yeah, because if you produce one per 15 seconds, you will create new product, or 6 seconds per one product. Even 500 milliseconds is very, very worth to know about it if it's bottleneck. But without capturing the long-term data, you cannot see it. Yeah, you can see it, for example, every Friday when you have lots of produced parts, and you will see, okay, we have some lower productivity than we expected. So you will start to analyze it, but find that some cylinder is slowed down even for 500 milliseconds. It's almost impossible, because during each production day, you will have the small issues on lots of things. Yeah, some bad input material, some inspection will fall down, or you will have a different degrees, or whatever. Yeah, and these small things can affect this production too. So you will see that overall slowing down of this production line is 500 milliseconds per each product, but where to find it in this all of mass of these informations? That's how the tools and automatic analyzers and anomaly analyzers on clouds can help you to find this and improve your production. But you have to collect this data.
Yeah.
And for most of the factories, it's a huge problem to collect this data from all of these sensors and all of these cylinders, because they have the old system of the connections. And the throughput through the PLC, which is designed for controlling real-time application, is not designed to handle too many of these data. That's why the other system is created, like OPC UA and MQTT and other protocols, and it expects that most of the sensors will be connected directly to some orchestration platform like ThinkWorks and these things, which can reconnect it or resend this data to automatic analyzers to get this feedback. So I'm sorry for a little longer explanation, but it's very, very difficult to understand all of these small pieces together and get this puzzle together. So
yeah, no, I think that's great. That's great, Tomas. You've shared really some of the details and the struggles that we see, even before somebody has the 4.0 standard, let's say, in their manufacturing plant. But that's why we got to leverage the new technology like IoT, and we can process things on the edge versus the everything connected to the cloud, which is, as you know, this is becoming a bottleneck now, as Irene had mentioned. But Tomas, maybe you could share with us, I think the convergence of all these technologies coming together we're in a good spot for that. But maybe you could share, is it the challenge to get people to adapt 4.0, Industry 4.0, or is it really, do you see technology challenges? I don't see that now because we're at a phase, but maybe you do, and maybe you could share that.
Yeah, the main goal or some challenge in the industry is the brains of the managers. Yeah, because they don't believe that if they would change some information system or some architecture, just connection between today's systems, they will not need to change the ERP. They will just change how it communicates with other systems. They don't believe that it will help and it will save. And it's very hard to calculate it and convince them that it will work. And this blocks most of the factories and also some bureaucracy, because if this factory is owned by some global leader, it will take a long time before they would decide to change something in their production. Yeah, so this is maybe good biggest challenge ever in the whole implementation of Industry 4.0, because for the partial or parts of the Industry 4.0, there are lots of solutions. Maybe another challenge is select the right one. So I recommend, if you're a factory, you must find some specialist which will do maybe half of a year or maybe 1 year. It will take to do really detailed analysis of processes across the factories, because to be honest, most of the factories doesn't have a detailed description of the processes which match the reality. They maybe have some description of processes, but usually it doesn't match to reality. But when you want to control process and give the feedback to the production, they have to prepare this. If they don't have resources, like persons or specialists who can do that, they have to find someone as soon as possible. Yeah, there are lots of companies which understand these systems and these ideas. So I think before they will find someone and analyze their production, they cannot move forward. Then they can, after this, they can buy some fancy robots and 3D glasses and everything. But before that, don't buy it, don't implement anything before you will analyze all your production.
Tomas, that speaks volume to me, because the moment we started with high-tech conversation, we quickly diverge or really logically come to human element. All right. And of course, it's a tool, right? It's a tool in the hand of humans. So to me, this brings to very basic idea of process automation and process mining first, process discovery, understanding those bottlenecks and those right places where efficiencies can be gained. So my background is business process automation in a lot of way, and decision automation. And of course, again, the elephant in the room here is AI. I love to talk about, how the new shiny toy is improving, because what you're bringing is very realistic, very pragmatic picture, in a way that many companies really not up to far-reaching, shiny toys for a number of reasons, right? They still cannot figure out how the current process work. So where this complexity, you think, between human technology and really what's realistic?
The most important are people in it all the time. Even if we will have the most sophisticated AI, there will be some people who will block the transferring data to the AI to let them work. Yeah. So I will maybe a little stop on this the AI and how to use it in industry, because if we will take that you have described the processes, the bottlenecks, you will or change all the structure and architecture of data system in your factory. You will be very, very close to use some AI to analyze this data, but each AI must have some valuable or some value to your processes. So you will have to correct or select correct data, and it's not easy, because you have, for example, thousands of the tasks which can be automated, which can be analyzed by some artificial intelligence or some machine learning, but you cannot apply it for anything, every or all of these thousands projects or use cases at the same time, because you will not have resources to analyze the profits from it. Yeah. And so even the selection of the correct cases for the AI, it's very, very hard in this factory. And again, most of the factories cannot do it by themselves, and they need to find someone. And another very huge block for most of the factories is where to store the data, because they want to have them secured, but most of the factories trying to build their own data centers, but it will slow down the speed of the communication with some AI, which should run in some cloud, to be scalable and be as fast as possible. But lots of these factories, and we are going back to the people and how they block it. They don't want to share this data to some cloud because they worry that on cloud someone can steal it. So they don't provide to this AI tools data just because they're scared that someone can steal it. Yeah, and that blocks a whole for example, automotive is blocked very, very much because of that. Yeah, so they have to find some different way how to store data. And I think, for example, interplanetary file system, it's a very, very good step how to provide amazing amount of data across the planet to learn the AI. Yeah. Because if the factories will keep these data privately, they will not allow to scientists and developers to build the AI. Yeah, because they will need to build it just for some case in some factory, and if they want to increase the knowledge of this AI, they need to do contract with another factory and lots of paperwork just because of handling data, which you need to learn this AI. Yeah. But when we will find some correct way how to store this data globally, and for example the blockchain with combination of IPFS can be the way how to provide or create and provide amazing data set for learning AI. Yeah, because lots of the cases in the industry will repeat. Yeah, for each year in different factories across the world. So if we want some very smart AI, they need to know about these previous cases and checking this data in long term. Yeah, but to remove this scare of the factories or the factories owners that someone will steal their data, they can do it in anonymous way. Yeah, they will describe very easily some situation to the blockchain metadata and attach some, for example, X-ray image into the IPFS, and this connection will be provided as a set of future learning database for any purposes of checking some errors during the production. Yeah, I think before the real implementation of AI in the industry, we have to focus to how to collect the data globally. Yeah, because if factory will just store the data of one product and it will be same all the time, it will not be too benefit or it will not bring too much benefits into the whole planet use of AI. So I'm maybe a little
Makes sense, Tomas. Absolutely. Yeah. To the audience that's watching us right now, please put questions in the comment. We can ask Tomas questions live, so please use that opportunity, huh, Brian?
That's right. No, we like that. In fact, we hope to get more questions through this live show. Of course, we try to keep it to 30 minutes, but sometimes when the questions start coming, maybe Irene and I won't be asking the questions anymore. You know, who knows? But
ideally,
Tomas, ideally. But Tomas, last thing for me today, anyway, before I turn it over to Irene, what I'm hearing though is what's showing the most promise as far as the technology platform is blockchain, because that may provide some sort of governance around what we're just talking about, security, and people are scared to put it in the cloud and that sort of thing. What do you say to that? Is blockchain a way to help manufacturers and CEOs of those companies to provide some sort of protection around their intellectual property using blockchain?
Partially, because you have to find the smart cases where you can use it and where it worth it. Because the storing data on blockchain, even there is no fee, it costs something. It costs some energy, and you have to understand where to use it, because you cannot collect you cannot collect the data to blockchain from each sensor in your factory. It doesn't make sense. Yeah, but for example, I expect that in future automotive production, if each production will start with minting NFTs. Yeah, so for whole car you will have an NFT for, and it will be it will carry the data about the customization, which is very important in whole industry 4.0, because each car can be different, and then it will split to some parts, and for each part in the car you will have own NFT, and there is maybe 12,000 parts in each car. With the bus engine, yeah, with in electric car there is less components, but during where the blockchain can help these factories, it's not to manage digital assets. I think the intellectual property can be covered in lots of ways, but the most important use case will be the traceability through the production. Yeah. So with each part, with unique ID, you will have on NFT, which will track each step in the production, and you have to consider if it will do some action in each station on the production line, or each step in the factory, like each production line or pressure device or casting device, whatever. This is the way where the blockchain will be the leader in the future data handling in the industry. Yeah. And it can
Tomas,
help.
first question. Yeah, first question we have from Anzar Hassan. Hello, Anzar. Thank you for watching. The question is around intelligent automation platform. So if I understand it correctly, how mature you think your intelligent automation platform? In a way that, it's not clear.
I don't get this question.
It's not clear, but yeah, let's talk about intelligent automation, because it is related. I believe it's related to Industry 4.0, and it is, right, AI insights in the processes, in decisions. So how mature you think AI technology is at the moment? Could you share?
Without the all of the softwares which is prepared for it, amazing. Yeah, for example, if you know the ThingWorks from PTC, you can totally automate the whole decisions in the factory related to this data and anomalies in the factories, orders and everything. But the main problem is you're missing the data, and without it, you cannot do these kind of automations. So the technologies are mature, but the data and the architecture in the factories are not. Yeah, so
and this is excellent point, Tomas. Yeah, because that entity or person who holds the data will have the answer, right? That's why so many people refer to digital giants, because they collect the data, they have enough volume to analyze and to draw the conclusions. Okay, and maybe every single medium, small enterprise cannot afford to collect that data, to store that data, to pay to store that data and analyze it. So yeah, that's definitely. Brian, you were saying?
But
no,
they can sorry, Brian.
No, Tomas, it's fine. I just wanted to see if there was any other questions that may have come in, and it doesn't look like it. But go ahead, Tomas.
Agree. It's dependent on data. What lots of factories can do: start with some smart orchestration platform software. For example, I tried the ThingWorks, but it's you have to pay for it. So you can find the similar tools like Node-RED, which is free, and you can start to try collect some data with it. It's very, very simple. And if you will start, for example, on one production line, you will little move forward. Yeah, so I can recommend to do some experiments with the ThingWorks and how to connect the things or entities with these kind of softwares, and then you will be able to explore the automation of the processes and intelligence decisions. Because you have to do it. There are too few people who can control the factories now, and I think there will be more factories than smart people. And so we have to automate it.
And democratize, right? Democratize technology and knowledge. That, I get it. Yeah, Brian. In conclusion, though, right? This is fantastic talk, but in the in the interest of time.
I think that in the interest of time, it was amazing information that you shared. Again, another topic we could talk for hours on, Tomas. So thank you. I certainly appreciate it, and this adds a lot of value to the listeners today. And again, we're streamed, Irene. We're streamed on YouTube, LinkedIn Live, Twitch, and Facebook, all live. We're getting an incredible audience growing out of this, and it's because of great guests like yourself, Tomas.
Tomas, thank you so very much. Come back soon, okay, with new hot updates, because we love talking to you. We love hearing your point of view. Thank you, gentlemen, and thank you to our audience who are watching and commenting. Come back.
Thank you too. I agree. We should talk hours about it because it's so huge topic. So I hope we will do a next part of it. When
Loving
it. Yep. Enjoy your weekend, everybody.